Welcome back. Here we go. Basically, we are going to take a lot of this physics stuff that we've been taking a look at. We're going to put it all together and we're going to do a little projectile motion. Now, we're doing basically a simplistic form of projectile motion. We don't know that many formulas. We're going to use what we've done so far. We're going to use the formulas that we do know. And we're going to do our best with a little projectile motion. Okay? If I kick a soccer ball at 45-degree angle at 8 meters per second, I want to know how long will it be airborne, how far will it go, and how high will it go. Now, that means I got my nice little soccer ball. We'll put it right here. I'm going to kick it at a 45-degree angle. Now, the path that it's going to take, it's going to look like a parabola. You learned that in geometry class. It's going to look like a nice, perfect parabola. And that was at 8 meters per second. Now, this is the whole trick with projectile motion. To take the angular momentum, the 8 meters per second at an angle, and change it to the momentum or the oomph, or you could say the speed that it's going up and the speed that it's going out, okay? You're gonna change it into the vertical component and the horizontal component, the vertical movement and the horizontal movement. Now, basically we said before, this is a 45-degree angle, makes it a little bit easier. Picture this arrow being over here, and it makes a nice little right triangle kind of deal. I did that just to make it easy. Once again, this is a freshman science class. I don't assume that my students know trigonometry. Some of them do, but not all of them. And so we're just gonna make this a nice easy 45-degree angle. If you know trigonometry, you could kick the ball at any angle and you could get your data from it, okay? So let's see here, 45 degrees. We're gonna use a squared plus b squared equals c squared. We're gonna use Pythagorean theorem. The only one of these that we know is c. C is gonna be that 8 meters per second, so c squared is going to be 64. But A and B, if it's a right triangle, if it's a 45-degree angle, A and B are going to be exactly the same. So it's fair to say A is going to be half of 64 and B is going to be half of 64. Now I did say that wrong. That means A squared would be half of 64, which is 32, and B squared is going to be half of 64, which is 32, okay? We're just going to say A squared is 32. You take the square root of 32 and you get, I am rounding off, but 5.7 meters per second. The square root, to get A squared down to A, you take the square root of it. Well, you have to do the same thing to this thing too. The square root of 32 is 5.7. I'm rounding, but about 5.7. That means the oomph going out is 5.7 meters per second. And you can also say B is going to be the square root of 32, and that's going to be 5.7 meters per second. That's going to be the oomph going up. So now we broke it down into our vertical and our horizontal components. Let's take a look at how long will it be airborne. Well, we have a few different formulas. One of them that I remember is V equals G times T. I like that one because it has a velocity. It has a gravity. Gravity is going to be directly involved with how long it's going to be airborne, and it has a time. And how long is a time? That's what we're looking for. So V, the oomph going up is 5.7 meters per second equals G, 9.8 meters per second squared times the time. So if 5.7 is the oomph going up, we can solve this to get the time. Now keep in mind, velocity is directional. That means this will give me the time, but it'll give me the time it was going up. Now I'm going to round it out to 0.58 seconds, okay? What I did is I divided both sides by 9.8 to get 0.58 seconds. So time is 0.58 seconds, a little bit longer than a half a second going up. I'm also going to say the total time airborne is 1.16 seconds. Now, that's just 5.8 times 2. If it took 5.8 seconds, 0.58 seconds going up, It's going to take 0.58 seconds coming back down, so a total of 1.16 seconds. That's how long it's going to be airborne. How far will it go? We have to go way back and use a different formula for this one. Speed equals distance divided by time. Now you could get this using different formulas, but we're just going to work with the formulas that we've already done in class, the formulas that we already know. Now keep in mind this one, there's no gravity in this one because gravity is not pulling it sideways. Gravity is not a direct influence on how far it goes. It's going to be influenced indirectly. It's going to be influencing it by how long it's airborne, how long it's up there, stuff like that, but it's not a direct influence, okay? Our speed going sideways is 5.7 meters per second. That was the oomph sideways. We don't want to use the oomph on an angle. So 5.7 meters per second equals distance, that's what we're looking for, divided by time. Now, here we have to make a decision. Do we want to use half time or full time? Well, it's moving sideways, whether it's going up or if it's going down, it's still going sideways. So I'm going to use the full time, the 1.16 seconds. Multiply both sides by 1.16 and I get a distance of 6.6 meters. Distance is 6.6 meters. So I know from here all the way to here is 6.6 meters. So now we got how far did it go. We know how long it was in the air. We know how far it went. I now want to know how high, how up in the air, what the distance is right here. How high did it go? Okay. For this one, we have to go back to distance equals 1/2 g times t squared. Now I want you to notice gravity is in here because gravity is a direct influence on how high it's going to go. Distance, how high it goes, equals, well, half a g. G is always 9.8, so half a g is going to be 4.9 times time squared. Once again, we have to decide what we're going to use, half time or full time. Well, I think I'm going to use half time because it was only going up for 0.58 seconds. It was going up for the time that it was actually going up. So this is 0.58, and you do have to square that. 0.58 times 0.58 times 4.9, you end up with a distance of, and I'm rounding here, but 1.6 meters. So if you kick a soccer ball 8 meters per second at a 45-degree angle, it will go 1.6 meters into the air. It'll go a total of 6.6 meters before its first bounce. That's the first time it hits the ground. And it'll be airborne for just over a second. So hopefully that gets you a little bit closer. Projectile motion, pretty tough stuff, especially when we're using a limited number of formulas. We're only using the formulas that we've already done in class. But it does work out, and yeah, hopefully you have a great evening. Bye-bye.